Those are like the kind of dark ages of accessing simply just the files you need to run. That is, if you're even given the files at all. Sometimes it would just be email the author or fill in this web form, or we'll post you out something on a CD or floppy disk or a tape.
All right, welcome to another episode of the Bioinformatics Lab podcast. I'm Kevin Libuit with Andrew Page. We're from Fusion, and today we're going to be talking about best practices for public health bioinformatics pipelines. As we've mentioned on various episodes in the past, you and I are both part of the Public Health Alliance for Genomic Epidemiology. I am a current member of the Pipelines and Visualizations Working Group, and we've been, for the past, long time, maybe 18 months or so, we've been cobbling ideas on this effort to create a document that articulates best practices for pipeline development for resources that are specifically tailored to public health use. And you obviously have tons of experience in writing bioinformatics software that is being applied in public health, but I'm curious, even if we start off, what best practices did you adhere by? There were no really written rules. That's kind of the tagline of Micro Binfi, really. So how did you guide your best practices when putting resources together to start things like Rory as an example?
Yeah, I guess back in the day, in dark ages of bioinformatics, things are very different, and we messed up quite a bit. So I don't know if you remember it. It was not Stack Overflow, SourceForge, where
Yes.
you'd go and you download stuff. There'd be a million different ads, and you might get a file, and you can add a premium download speed, and then sometimes you'd even bundle in, like, I don't know, Yahoo toolbars and stuff like that. Like crazy, crazy stuff. Like, and it wasn't free. It wasn't necessarily open source. That kind of stuff. So, those are like the kind of dark ages of accessing simply just the files you need to run. That is, if you're even given the files at all. Sometimes it would just be email the author or fill in this web form, or we'll post you out something on a CD or floppy disk or a tape. So bioinformatics has come an awful long way, and I think a lot of it is down to, say, GitHub. What about you? What do you think?
That's exactly right. And I think that you're speaking to the Dark Ages is funny because it was very ad hoc. It was very much still in the cauldron of academics of trying to work things together just to get things to work. But the field has matured so much where now there are standard implementations like GitHub and just general best practices that have emerged but not yet fully articulated. So that's the intent of this document, is to get those best practices written so that we can at least start as a nucleating point for the field to start the discussion. Hey, let's get a rung in the ladder. We have surpassed this step, so we can all expect everyone to use that. So today, and maybe on a couple of different of these episodes, I'd like to walk through these best practices proposed, talk about them, get your thoughts on them, and really more than anything, encourage community feedback on what we put together here as a resource. So 10 best practices. Let's hop into it. Yeah.
Yeah, and I guess if you're just starting out in this world, you don't necessarily know what to do. You don't know what you should do, and this hopefully will give you an idea. From an international consortium where people actually know what they're doing, and they've been in for a long time, and so they've made all the mistakes, they've seen all the bad things, and they want to avoid all of those. So, the very first thing is probably just making sure the code is available. So what do you guys think on your committee?
This speaks to exactly the challenge you spoke about with SourceForge and digging through different kind of resources, be it email forums or email the author or whatever it might be, to actually just get access to the source code itself. And in terms of the 10 best practices, one and two probably go hand in hand. The first of which is ensuring that it's a publicly accessible repository, and the second of which ensuring that there's some kind of open source licensing made associated with the repository itself. And these two, again, we've harked on these two subjects in previous episodes, but it's worth highlighting again how important this is to public health world, in that there's a transparency to making these resources available that benefits the whole public health community, because if you're making a tool that's useful for one lab, it's very likely that it's going to be useful for a whole number of different laboratories. And so making sure that it's both publicly accessible and that it's something that's open source so that other practitioners can adopt it and continuously improve upon it. Hopefully, these are relatively uncontroversial best practices to be implementing in public health software. Yeah, what are your thoughts there?
Well, yeah, I mean, the classic arguments are that, well, I don't want to scoop to my own work, I don't want to put it out there, or I want to keep it on my institute's repository or my random F2P site, that kind of thing, or I want to retain control just in case our someone wants to commercialize it, in a university. That's a big thing, where they want to make money from their investments, but at the same time, it means it hinders uptake and usage. So there can be a trade off there. So just having it somewhere, and also somewhere where if you leave university or you leave an employment, it's not going to disappear overnight. You know, that's the good thing about these, I suppose, cloud based independent platforms like GitHub and GitLab and whatnot, where it's not attached to your place of employment. It's often within an organization, but it's not going to disappear. And so you don't need to worry about that. And then open source licensing, that's a minefield, Actually, the worst possible thing is not to have a license at all. You want to make it open source and you put it on the web. You don't say what license it is, and you have to assume the worst. And you have to assume that it's not open source, it's not freely available, it's just there, which is not good. So always put an explicit license on there. I personally use GPL3, have done for years. I'm sure there is other licenses out there if you feel the need for them, but it's a very deep technical thing. Legalese, I don't fully understand it. You need to talk to other probably lawyers to understand all the intricate details of those. Some allow for commercialization, some don't. Some require code to be made available, or they're infectious, others aren't. So there's a lot to take in. But just make sure you actually have a license and have it in a file so that people can actually read it when it's distributed.
And that's why we really wanted to add that as a best practice in the field, is that the author should indicate what license that they care to adopt for their software. Otherwise, people are just left to assume, and that just leaves room for ambiguity and challenges as people implement your software and maybe fork and pull it into different kind of environments. So, yeah, moving on to the third one, version controlled software. Again, a best practice. Like, there should be some implementation of semantic versioning as opposed to just people forking the main or cloning the main branch and hoping it stays somewhat static. I know in the StaffB Docker world, when we create Docker images, we want to ensure that they are as static as possible. And it's always a challenge when version control isn't implemented in any way. So we go as far as, when we create those Docker images, pulling a specific commit so that we know that the commit is static at least, as opposed to maybe pulling from main, because as we know, main can be dynamic. So yeah, again, hopefully uncontroversial on version controlled software, but yeah, what are your thoughts there?
Yeah, I guess there's a lot to it. It's not just putting your files into version control. It's how you do it, and that's kind of comes back to, say, software engineering best practices. So, labeling your commits so that people can follow what happens, making them granular enough but not too granular. Um, so that if you need to pull something out, it's easy enough to pull out that functional change or that bug fix, and then documenting that process. What has it actually changed? Why have you done it? Um, and why did you maybe not do something else? And it's just about, yeah, giving your insights into what you're thinking at that particular time. And it is very, very important. And it's important as well, that people can see the evolution of your software. So if in the future there's ever issues, I don't know, patents or something like that, it's quite useful to have version controlled software, because you can show, actually, I didn't come up with this, I didn't steal your code, I didn't come up with it, magically overnight. It's a stepwise progression. You can see all the changes over 6 months or a year, and that proves that you have authored this properly. Um, And then you're talking about semantic versioning. Like, yeah, absolutely, totally important. Because when you do just blindly use version control software, obviously you get the hashes, which are letters and numbers. Don't mean anything to anyone. But, a version number, that does. And for historically, people have done it in every possible different way, like using dates, using letters, using a whole range of things. Whereas the simplest possible thing is just, three different numbers, like the major changes is the first number, then kind of minor changes, maybe add new functions, and then the last number is patch changes, like say security fixes or there's a bug or something like that. Very simple, and then people often just forget about that.
Moving on to the fourth best practice. This is actually where there may be some contention in this. As a sub working group, we intentionally focus this on pipelines best practices. So that's specific to this categorization or best practices number 4 in implementation of some kind of workflow management system. I think there has been just growing number of evidence and obvious, tangible benefits of user experiences in implementing the workflow management systems that are already out there. Includes things like obviously Nextflow, Whittle, SnakeMake, CWL, the Common workflow language, all these resources and infrastructure around them that help to create a pipeline and ensure that there's some standardization, one, in the development practices, the language that's being used, the interoperability afforded by these different workflow management systems in terms of being able to run them on different environments and infrastructure, ease to incorporate things like containerized software, all the rest. We felt that was the best practice in pipeline development at this point. Probably something that we've seen emerge over the last 3 to 5 years, but at this point, there's really no need to encode your own logic in your own Python libraries or Bash, whatever is in the background, because these resources are so robust.
So, what is your favorite workflow management system, or is that kind of a bad question to ask?
I favor two. I like Nextflow and Whittle quite a bit. Nextflow, they're very similar. I would say that too. I've even written a little bit in SnakeMake, but they're all very similar in that they take the concept of individual analytical modules like tasks and then wrap them up into these pipelines. I know Joel likes to call it really like it's the duct tape of the software development. I like Nextflow because of the incredible community behind it and the immense flexibility you have as a developer. And I like Whittle because of the compatibility and actually the rigidity to it. The compatibility to things like Terra and DNA Nexus and other sort of user interface access points to these workflow management systems. So, but that's a preference. So long as someone's using it, I think we can port it over into downstream processes.
What people don't realize is a lot has changed over the past few years. Over the past decade, things have changed. Because in the olden days, people would, knock out a bash script, or they go to their Slurm cluster or whatever, massive physics cluster, and be uploading jobs and be very bespoke, and it wouldn't work anywhere else, and it was super tied down, and it was a lot of work to manage. I know in the Sanger Institute when I was there, we counted up at one point there's 7 different massive workflow management systems internally developed, and if they'd all put all their resources into one, they could have had something very good. But what they had was 7 different ones, which are super localized, just to the infrastructure that was available. So I'm actually delighted, things like Nextflow and Whittle, because they can run anywhere. And oh, don't forget Galaxy.
Yeah,
Galaxy is
absolutely.
often forgotten about, but it has a lovely drag and drop interface for developing workflows. And I've seen experimental scientists, do the most phenomenal complex things with bioinformatics just by dragging and dropping, and doing serious data analysis without having to actually get their hands dirty in the command line. So yeah, there are many ways to do this as long as you use an actual workflow management system and you don't reinvent the wheel.
Absolutely. I'm glad you mentioned Galaxy. I don't think we wrote that one down as an example. I'll be sure to include that. Shout out to do they call it the intergalactic community who are putting all those resources together that are front facing through the Galaxy platform. Good call. All right, number five, and probably the last one we'll be able to get to in this episode, but we can end it here. This is a great one. We've talked about this again in the past, but containerized and packaged software, huge for interoperability. Again, we've highlighted this topic in the past, but always worth reiterating the paradigm shift that Dockers and containerized software and even package managers have really brought to the field of bioinformatics. And maybe you could speak again to the how we've transitioned from the dark ages into where we are now because of these technologies.
Well, actually, to be honest, it's this is what Staff B is known for, and maybe you should comment on this because that is probably one of the best outcomes I've seen in bioinformatics in a very long time. You know, that we have all these containers for bioinformatics written by bioinformaticians. So yeah, tell us more about how Staff B is working in this space.
Yeah, Staff B, for those of you, the folks may be unaware, Staff B is the State Public Health Bioinformatics Working Group. It's a consortium of U.S. practitioners that are trying to address all the challenges that inhibit implementation of these kinds of technologies in public health. And one of those major challenges has traditionally been access of interoperable software, because there was always the conversation when you see different publications on algorithms of maybe some install instructions or something like that, and showing how to get access to these kinds of resources. But then you go through this whole process of you trying to download that software, then you realize, oh, there's dependencies on dependencies on dependencies, and if you have the wrong version, you're inevitably going to be stuck. Either at best it's non-functional, or sometimes at worst it's functional and but discrepant from intention in a way that's difficult to identify. So like it might be running and you see completion, but it actually may be doing something that you are unaware of it actually doing, because you have the wrong dependent software of a blast version that was, in some way deprecated or something of the sort. So what we tried to do in Staff B is exploit the utility of containerized software, create those standardized environments that rather than trying to install locally, you could just run something like Docker. You know it's going to be a static and reproducible environment, and then something that works on my machine will inherently work on anybody else's machine who's able to access those Dockers. So at this point, there's hundreds of Docker images for the widely utilized software in public health bioinformatics. This is a resource that's been instrumental really to the global public health community. I think it's millions and millions of polls from practitioners in countries all over the world. And it's helped to standardize things. So not only when you're interacting with the algorithm at the single use level, but whenever you're starting to write packages and pipelines, it's really become the best practice, as opposed to having some kind of install script in your workflow, or something that's dependent on a module within your big cluster. It should be incorporating these standardized container images here.
Awesome. Well, I think we'll leave it there, and we'll come back with the next five of that 10 best practices. Thank you very much, Kevin, and we'll see you all next week.